Lesson 13.1, found on page 515, deals with patterns in data. The essential question, how can you describe overall patterns in a data set? Seeing data sets in graphs such as dot plots and histograms can help you find and understand patterns in the data. All right, so here's our first problem. Many lakes and ponds contain freshwater fish species such as bass, pike, bluegills, and trout. Jacob and his friends went fishing at a nearby lake. The dot plot shows the sizes of the fish that the friends caught. What patterns do you see in the data? So this is the length in inches. 5, 6, and 7. Then there's like this gap right here. And then 11, 12, 13, and 14 inches. It says circle any spaces with no data. Well, that's these. Place a box around any groups of data. I should probably include the numbers there. This probably should have come down below. There we go. Analyze the dot plot. A gap is an interval that contains no data. All right, does the dot plot contain any gaps? If so, where? Okay, yes, from 8 to 10, there's a gap. So were there no fish? So there were no fish from 8 to 10 inches long, and there were two clusters of fish measuring from, say, 5 to 7, and then 11 to 14 inches long. So a cluster is a group of data points that lie within a small interval. So there's a cluster from 5 to 7. I guess I should have done this first. And 11 to 14. All right. So now let's summarize the data on our dot plot. So essentially, the dot plot shows that Jacob and his friends caught fish this many inches long and then this many inches long. They did not catch any fish in this range. Basically, that's all we're saying. Okay. The dot plot shows caught fish that were 5 to 7 inches long, and what was it, 11 to 14 inches long. No fish 8 to 10 inches long. All right. What conclusions can you draw about the data? So what can we conclude about this? The first thought that comes to my mind is that notice that they talk about a variety of species. Well, bass, pike, bluegills, and trout are all different sizes. So maybe they caught some bass and some bluegills and they're, you know, in roughly these ranges. So they probably caught two different species of fish that were roughly the same size. You know, like a Chihuahua and a Great Dane are not the same size. They're both dogs, but they're not the same size. And this is kind of the same concept. There's two different types of fishes, but they're not necessarily the same size. So that's my guess, is the friends caught two different types types of fish. One that is usually 5 to 7 inches, and one that is, I'm going to come down here, usually 11 to 14 inches, basically. All right. All right, so you can analyze patterns in data that are displayed in histograms. Some data sets have symmetry about a peak, while others do not. So this one kind of has symmetry about a peak, this being the peak in the middle. And these are roughly symmetrical coming out. There's a step down and another step down, is what they're saying. Okay. Erica made this histogram to show the weights of the pumpkins grown on her father's farm in October. What patterns do you see in the data? So there were number grown. So there were roughly 50 pumpkins grown that were 0 to 10 pounds. There really wouldn't be a pumpkin that was 0 pounds. That's doesn't exist, right? We'd have to have some weight, but anyway. All right, then 11 to 20 pounds, 21 to 30 pounds, 31 to 40, 41 to 50 pounds. That's a big pumpkin. All right. Identify any peaks in the data. Well, this is our peak right here in the middle. So there's one peak right there. The interval representing the greatest number of pumpkins is for weights between 21 and 30 pounds. So most of his pumpkins were this size, right? Or I should say the greatest number in one category was this size. So between 21 and 30 pounds. Describe how the data changes across the intervals. All right, the number of pumpkins increases from 0 to 30 pounds. Boom, boom. See how it's going up? And then it starts to decrease from 31, or I should say 21, sorry, down to 50. So I should say 21. Okay, let me try that again. The number of pumpkins increases from 0 to 30 pounds. It just continuously goes up. Then it starts to drop off from 30 down to 50 pounds. All right, describe any symmetry the graph has. If I draw a vertical line through the interval, vertical line, vertical is up and down, through the interval for, describe any symmetry. Oh, I see, I get it now. Okay. So if I draw a vertical line, and let's say right through this middle, right through the middle, through the peak, and if I were to fold it on that line, oh, I was close. Let's try that again. And I was to fold it right on this line. Let's say my folding was better. Notice how it's pretty symmetrical coming out from this line. So this is a line of symmetry. That's what they're getting at. Okay, so if I draw a vertical line through the interval for, all right, 21 to 30 pounds, the left and right parts of the histogram are very close to being mirror images. They're not absolutely perfect, but they're very close. The histogram has, so therefore the histogram has a line of symmetry. So the data values increase to one peak. Let me straighten that out, sorry. So the data values increase to one peak in the interval for 21 to 30 pounds in the middle, and then decrease. So it goes up and then it goes down. The data set does have the data set has line symmetry about the peak. Maybe it'll give us... Okay, let's take a look at this one, just so you have a point of reference right after talking about that. This, it's kind of symmetrical also, but it's symmetrical around a gap instead of a peak. But not perfectly, not as symmetrical as this one was. Let's pull this one back so you can compare them better. See, this one's pretty darn symmetrical. This was kind of also, not as much, but kind of. All right, let's take a look. The dot plot shows the number of paintings students in the art club displayed at the art show. Does the dot plot contain any gaps? If so, where? Well, yes, it does. Right here at 5 and 6. So we would answer that as yes, 5 to 6. Identify the clusters. Well, this is a cluster. But this isn't a cluster. This is more like an outlier, right? This isn't a cluster. This is a cluster. So there is one cluster from 1 to 4. Summarize the information on the dot plot. Okay, so, whoops, sorry. All right, students, so we'd say students displayed 1, 2, 3, 4, or 7 paintings in the art show. Most displayed one piece of art, and none displayed 5 or 6. Pieces of art. Nobody showed up with 5 pieces of art or 6 pieces of art. One very ambitious kid showed up with 7, but most of them showed up with 1. All right. What patterns do you see in the histogram? Let's see. Monday Zoo visitors. Our intervals are 0 to 9, so basically 10s. Here we have our count bys are 25, 0, 25, 50, 75. So this is the number of visitors, and this is the age of the people visiting. Okay, so that makes a little bit of sense now, because you're going to have little kids showing up at the zoo, and then you're going to have older people who don't have a job showing up at the zoo, right? So, I mean, there's going to be a handful of young parents of little kids bringing their group to the zoo. But on a Monday, most people in the middle range here, these ages are going to have a job and they can't take time off to go visit the zoo, right? All right, so the data has 2 peaks, here and here, very old and very young people, right? So the data has 2 peaks at 0 to 9 and 60 to 69 years old. Okay. The number of visitors decreases from 0 to 29. From 0 to 29, it goes down. And then it increases from what? 40 to 69. Decreases from 0 to 29 and increases from 40 to 69. There is a gap in the middle, which is what, 30 to 69? Or 69, 39, 30 to 39 years old. Okay, great. Go ahead and give your PMT a try.